All right, looking at the muscular system. When we look at MUS, beginning with muscular system, that is Latin for mus. Some people thought that the muscles look like little mice running underneath the skin. Somebody thought that. So if we look at muscle, there's 3 types of muscle that we studied in lab, and that is skeletal muscle, which is striated, has multiple nuclei, and smooth muscle, which is spindle-shaped, has singular nuclei per cell, and then cardiac muscle, which is striated and has a branched appearance. Recall that cardiac muscle has branched cells and those intercalated discs that we're going to learn about in lab. So when you look at the job of muscles, is they take that chemical energy in the form of ATP and they turn it into mechanical energy. And whenever we think of mechanical energy, we're just looking at physical movement. So muscles attach to bones and cause movement at joints, and movement of substances through the digestive tract, and urine through the urinary tract, and so on. So basic functions of the muscular system, key thing is movement. Maintaining posture, so the muscles of your back allow you to sit up or stand. Respiration, the external intercostals control the ribs by allowing you to inhale when they contract and pull the ribs outward. And the diaphragm is a really important muscle that contracts and moves down when you take a deep breath. So we need those very important muscles for breathing. Production of body heat, muscle is active metabolically. Just, sitting upright causes, uses some ATP, burns some energy, and releases heat as a waste product. So just sitting here is using energy in the muscles. And we know when we work our muscles, we get heated up, right? And then you sweat. So that's because muscles are constantly active, constantly using energy and producing heat as a waste product. Muscles communicate with one another. So they communicate via gap junctions in the heart. So an action potential in one muscle cell travels right to the next muscle cell of the heart, causing the heart to contract as a unit. Smooth muscle in the digestive tract, some of it, like in the digestive tract, can generate its own action potential. It's connected by gap junctions, and ions flow from one muscle cell right into the next muscle cell. There's no neuromuscular junction with a gap in between. They just flow right in between there. Constriction of organs and vessels, your blood pressure, like I said, movement of fluids, like your esophagus moves food down into your stomach by peristalsis, which is smooth muscle contraction. Your blood vessels move blood from the heart to the tissues through contractions of the heart, but also there's smooth muscle that lines our blood vessels that moves fluid through, moves the blood through. And your heartbeat is the result of the contraction of the heart itself, and the valves, when they slam shut, they give that lubbed up sound. So all of that is cardiac muscle, smooth muscle, or skeletal muscle working to maintain homeostasis. So you had to compare the 3 different types of muscle tissue in lab. I'm not going to go over the details of that again in lecture. Just be aware there's 3 types of muscle tissue and where we would find them and what their function would be. So smooth muscle propels things through the body. Cardiac muscle is the major force pushing blood through our vessels and into our capillaries. And skeletal muscle is movement, attaching to bones. So just basic functions. So if we look at skeletal muscle structure, we know that the cells are long and cylindrical. They have multiple nuclei, but the numbers remain constant, just like we saw in adipose tissue. When you're done developing and growing, you have all the muscle cells you're going to have for the rest of your life. You can increase the size of those muscle cells or decrease the size, but you're not going to increase the number of muscle cells. So the tiny contracting units inside of a muscle cell are called myofibrils. We'll talk about that. Those can increase the size of the muscle as we develop more of those, but we don't develop more muscle cells. The numbers remain constant. So when you look at the size, as far as length of these muscle cells, if you have a really long muscle, that muscle is made up of really long muscle fibers. So when we use the word fiber, we're talking muscle cell. So like neuron was a nerve cell, muscle fiber is a muscle cell. And we call them fibers because they're long and thin when we're talking about skeletal muscle. So when we talk about an increase in size in anatomy and physiology, you're going to see this word hypertrophy. Hypertrophy, hyper means high. I don't know what that means. I'd have to look it up, but it means increased size, hypertrophy. Atrophy is the opposite of hypertrophy, is when our muscles get smaller and shrink. If you don't use your muscles, they go weak very quickly. And a key thing to remember always and to tell your patients is that our body responds to the demands we place on it. If you don't demand anything from your body, those muscles are going to atrophy. So if you don't exercise and get your heart pumping, the heart is a muscle. And if it pumps hard because you're exercising, you're strengthening that heart muscle. If a person has a sedentary lifestyle, their heart is weak. And as a result, when they get a little exercise, they're huffing and puffing because their muscles are weak. They don't have a good storage supply of capillaries. When we exercise, we build more capillaries, but they don't have a storage supply of glycogen, and you're just huffing and puffing more. So we always need to have some exercise. They say mild, to moderate activity, which is like up to 30 minutes a day, most days of the week. So think about your lifestyle or the lifestyle of your family members, maybe that are struggling with weight control and overall health. Exercise is key. And it doesn't have to be fancy. Just going for a fast walk with your dog for 20 minutes at a bare minimum, getting that heart rate up and getting yourself huffing and puffing. I see people at the Y on the treadmill, and they're going so slow, they're not even getting their heart rate up or trying to breathe a little harder. That is good for just basic movement. That's better than nothing, right? But if they really want to improve cardiovascular fitness, they need to get that heart pumping and breathing a little harder. So looking at the properties of a skeletal muscle cell, what makes skeletal muscle cells unique from all other cells in the body is they can contract, so they can get shorter and pull on things around them. So when my biceps shortens, it pulls on my lower arm and causes me to bend my arm, flex my arm. Excitability, which means if I apply an electrical impulse to a muscle cell, it contracts. It responds to that electrical impulse. So for example, if you put your hands on an electric fence, what happens to your muscles? They contract. They contract. And if you hang on, and what happens, this happened to us. We were looking at some horses. I had my 3-year-old nephew, who's now 36, but he was 3 at the time. And we were looking at these horses, and he had his hand on the electric fence. And we didn't know it was electric. So he's like looking at it and swinging on it and just looking at these horses, and we're petting the horses. I don't know why it didn't happen right away, but it didn't. And he's sitting there, all of a sudden he starts screaming, "Ah, ah," and making all this noise. And I'm like, "Shh, you're going to scare the horses." I didn't know that it was electric fence. So I go to touch his shoulder to say, be quiet, and my hand goes boom. So it traveled right through him to me, and then I realized, and then my friend says, "Electric fence." So I just grabbed him by the shoulders and just ripped him off the fence, just did it really fast, and it was very scary. But he couldn't get off because it contracted his finger muscles right around the fence, and everything was contracted, and he couldn't release himself. So important. And then I was talking to some friends who have a horse, and they said that every now and then one of the horses of the 8 has to go up and check, does that fence still work? And then they hear it, zzz, and then all 8 of the horses run away from the edge of the fence. So there's always the one that has to test it, but the others respond and say, "Oh yeah, well, we're not going to go near that." All right, extensibility means we can stretch our muscles a little bit, right? It's important to stretch your muscles to keep flexibility throughout life. So that's another thing with muscle cells, is you can stretch them beyond that resting length and not damage them. And then elasticity is when you stretch them, they bounce back. For example, when you rest your arms to the side of your body, they're slightly bent. I can stretch it straight, make my arms go straight up and down, but when I relax, they go back to that resting. So they're elastic. You can stretch them out and they snap back. So elasticity is just returning to resting length, and extensibility means you're stretching it beyond the resting length. And smooth muscle is really extensible. We can stretch our smooth muscle of our stomach from our ribs down to our hips. Typically after Thanksgiving dinner is when we see that maximal stretch, right? Or anytime you eat a large amount, it can stretch. So looking at the parts of a muscle, starting from the inside, or from the outside in, sorry, the whole muscle is attached to bone via this connective tissue covering. So this connective tissue covering is part of the tendon. So the tendon is where there's no muscle tissue. It's just the band of connective tissue. Remember, it's that dense, regular collagenous tissue. And then as it covers the muscle, we call it epimysium. So epimysium and tendon, same tissue. It's just where it is. So that kind of white, glistening membrane you see over a roast in the grocery store, that's epimysium. And then underneath that are bundles of muscle cells. So bundles of muscle cells are called fascicles. So a fascicle is just a bundle of muscle cells. And it's surrounded by paramecium. So this here would be an example of a fascicle. So when you look at a slice of roast beef on your sandwich and you see the little circles with the white, you know what I'm talking about, the little white edges around the circle, those are fascicles. Those are bundles of muscle cells wrapped around a little connective tissue membrane. And you know you've cut your meat across the grain. Maybe you've heard that if you're making a roast or making something, they'll say cut across the grain. That's the best way to have a tender cut of meat, because when you slice it with your fork, you're just taking your fork and breaking apart the fascicles and eating that steak or that roast beef. If you cut it the long way, you're cutting through muscle tissue, whole muscle fibers, and that's harder to cut through with your fork, and that's because that's protein versus connective tissue, which is much more delicate. So you want to always be able to see little circles if you cut across the grain. And that's, again, surrounded by paramecium. So then if I go in here and I pull out what a paramecium, or what the paramecium covers, is muscle cells. So inside of this is a muscle cell, this is a muscle cell, this is a muscle cell, surrounded by endomecium. So endomecium surrounds muscle cells inside of a fascicle. So you've got the whole muscle surrounded by epimecium. You've got fascicles, which surround the muscle cells, surrounded by paramecium. And then inside the fascicle, you have muscle cells separated from one another by endomecium. And then underneath the endomecium is the plasma membrane of the muscle cell. And then these little tiny contracting units here inside the muscle cell are called myofibrils, which are made up of actin and myosin, which we'll get into that in more detail in the next lecture. So if we look at muscle cells in general and muscles, a motor neuron is what stimulates muscle cells. So we have a motor neuron, and then its axon terminals branch within the muscle. So each muscle cell has its own branch of a motor neuron. So you can see the yellow structures in there. Those are the branches, the axon terminal branches of the motor neuron. And you can see, does muscles have a good blood supply? Yes, definitely. So they do heal rather quickly if you tear a muscle. I mean, if you really rip it, and tear ligaments and tendons, that doesn't have as good of a blood supply, so that takes a little longer. But if you just strain a muscle from overworking it, or that feeling you get the day after maybe lifting weights or just doing some physical activity, maybe moving furniture, you get that muscle soreness, it's usually gone by the third day, wouldn't you agree? Because it heals pretty readily. So that's the good part about muscle. It has that good blood supply. But we also know what happens if I get a clot serving an artery to the muscle cells. Muscle's going to die, right? So people get clots in their deep veins of their lower limbs called a DVT, and then as a result, the muscle dies. Their leg gets cold and clammy and lack of feeling, turns blue. Those are all really bad signs that you need to get to the clinic and get that resolved. And those at risk for DVT, blood clots in the lower legs or the arms, are the elderly, pregnant women, because things change a little bit in the cardiovascular system with pregnancy. And if you sit for a long time and are on an airplane, that can increase the risk for DVT. So if you're pregnant and traveling on an airplane, it's important that those people get up and walk. If an elderly person is sitting on an airplane for a long time, it's important they get up and walk. Patients after surgery, can get through a blood clot. And young college-age women on birth control. Certain types of birth control cause an increase for DVT. So it's really important that they be aware of the signs and symptoms of DVT so they get that treated. And the neuromuscular junction, I have a nice video that goes with this, so I think we'll stop here and pick up with that next time.